Hey there, and welcome to this makeup video that I'm putting together for a live stream that I just completed up here at Epic. So, the story is today, at least for me, is October the 4th, 2018. I was just on a live stream, a training stream up here at Epic. And the short version is we ran out of time showing what I wanted to show. And because I can't always guarantee when I'm going to be available or actually at HQ to do these streams, I wanted to make sure that nobody was left behind and I was able to get the rest of my content out. I consider just picking up right where I left off on the stream, but if for some reason you missed it or any number of other reasons and you're like, well, I don't want to have to watch half of one video, then find the other half, I figured I would just start all over again and do it all over. I will do my best to figure out about the point where I left off on the video, which I think I remember where that was. And I will I'll put up like a time code or something so that if you did watch the live stream, you can just pick up right where this left off. We may still go ahead and complete that live stream, like with a part 2 in the future, but on the off chance that we either don't get to or it takes a long time, I didn't want to leave people hanging if you were finding anything that I was doing at least a little bit useful. So let's start from the very beginning. So here I am inside the Content Examples project. We're in the animation map, and I want to talk specifically about these sliders. So I'm going to hit play, and here we are. So you see we got this slider. I can hover over it and change its color. I can drag the mouse, and it drags back and forth. It's working. It's doing a reasonably good job. Uh, but the story is that I had to create a demo for GDC. I don't actually think it was either last year or the year before. They all kind of blur together for me. And I needed some sliders. So I started off by stealing these. I just grabbed them out of the Content Examples project. I slapped them into my new project. And the folks that I was building the demo for were like, hey, this could work a little better. And what they noticed was the slider can eventually get misaligned from your cursor, which feels really funny. So as I drag way off here to the side, you'll see it just kind of starts to fall off. The hovering is very precise, but that means like if the slider ends up accelerating past my mouse, it suddenly doesn't become clear which one I'm interacting with. It's great in that it's working, but it's maybe not the best it could be. It also maybe isn't the most efficient. So if I get out of this real quick, and with that slider selected, I'll open up its blueprint window. You'll notice it's doing pretty much all of its functionality on tick. And I'd really rather it not tick itself. We can pass it some events that take place at the same time as tick. But we're going to rebuild this in a way where it's more reliable. It does what you think it's going to do. The action, the functionality will be smoother, and it's not actually going to tick at all. Now, on the flip side of that, we're not going to bother implementing mouse wheel functionality. I never used it. I never was a big fan of it, so we're just going to skip that. So in essence, what happened is after I got done building this slider, I realized that this would actually make a great segue into a topic about building better blueprints, about focusing on best practices and how you should think about building things. So that's what we're going to do here. Now, generally speaking, across the board, I try to avoid the term best practice whenever I can because there's usually just best for the time you have available to you, which in any production environment is usually not much. So if you can't meet all of the standards and tick all the boxes for making your blueprints the best and most efficient they possibly can be, I get it. Sometimes you got to work quick, but we'll get as many of those in as I think we can. So for starters, I'm going to migrate this over to my project. So I've got the slider and the slider base static meshes. That's really all I need. So let's go ahead and get these migrated over. So asset actions, go to migrate, and this is fine. And I am on a Mac, so the way you do this probably be slightly different if you're on Windows. We'll go over to Documents, Unreal Projects, BP Slider Makeup, Content, and oh, looks like it's already there. That's perfect. But anyway, you saw how to migrate anyway. So let's cancel. Oh, actually, you know what? That's the wrong project. Bear with me. I restarted this video, this is going to be done off the cuff, so there may be a couple of things that you just have to kind of deal with me making some stuff up. But if I take a step back, my project content. Oh no, cool. It's in my project too. Awesome. Just wanted to double check, make sure it was already there. I'm not going to send it twice. So let's go over to my terribly named my project because I forgot to enter a name when I was setting this up, and that's fine for a demo. We'll just live with it. And if we expand this out, you see we have our demo room. We can open that up, and we have our meshes for our slider. Now, I chose the first person template for this because that already has a reticle. It has all the interaction points that we really care about. So that's how we're actually going to begin with this. So the very first thing I want to do is strip out the functionality that we don't actually need. Oh, also, I don't really like having a pawn already in my level, especially for demos, so I'm going to remove that. Let's go down to the first person blueprint folder, open up blueprints. Here's our first person character, and I'm going to start fixing this with a hammer. I'm just going to start ripping stuff out that we do not need. Let me make this nice and big so everybody can see it. So up at the very top on begin play, we have this HMD stuff for setting up VR. I'm not using VR, so I'm going to remove all that, including this. That can just go. So I want to keep the movement input. I want to keep the stick input just in case. Who knows? I'll keep the mouse input. We'll probably use that later. Down here, we have spawn projectile and all of the firing sequence stuff. All of that can go. We're not going to be doing projectiles. We're not going to be shooting. That can all just go away. Now, in my components, I do not need the mesh 2P, like the arm mesh, that can just go. I don't need the first person gun. I don't need this sphere component. I don't need the motion controllers, nor do I need the VR gun or the VR marker. We're going super bare bones here with just the things that we need to get rolling. Now, let's compile. That'll probably throw out a warning because there's probably some functionality we left behind. Yep, in the construction script, we were calling attach components on some stuff. Let's just remove that, recompile, and everybody should be happy, and that's cool. So now let's start setting up the functionality we need. Now, the way we're going to do this is our character is going to trace straight out from the camera as it hits things, as it traces against things. It's going to send an interface call to those to have something happen. The great thing about interfaces is you can send that call all day long. If the thing that you're talking to implements the interface, something can happen. If it doesn't implement the interface, then nothing happens, and that's perfectly fine. So we'll just implement the interface on the things that we want to interact with, in this case, specifically our slider. Okay, so let's take a step back from our into our level real quick. We are going to start by setting up the interface itself. As a quick side note, I pretty much never do this first, but because I want you to be able to follow along and have kind of a nice smooth flow to your workflow, we're going to build the interface first thing. So let's go, let's right click, we'll go to blueprints, we'll go down to blueprint interface. Now, let's give it a name. I'm going to call it interactable, or interactive. I like that better. So interactive, like so. Now let's open this up, and we need to start adding some functions to it. So if you're unfamiliar with an interface, it's just a bunch of unimplemented functions, and you implement the functions on other objects which implement that interface. It's kind of like having Mad Libs or like a fill in the blank that you can just put on other objects, and then it can mean different things. A really good kind of description for it, I think it's actually technically the way I learned it, is if I pick any one of you out there in the crowd and I say, hey, go get me a pizza. One of you might go and maybe go down to Domino's and order me a pepperoni pizza and bring it back, and that's great. Another one of you may go home and make some dough and actually get some cheese and sauce and stuff and make a homemade pizza and bring that to me, which would be better, but that's fine. But you both did two entirely different things with the same command, and that's kind of the heart of interfaces. I'm going to give out a single command that could be implemented in different ways on different objects. So let's talk about the types of functionality we need. So we need the ability to handle hovering, as our mouse cursor hovers over the slider. So let's have begin hover. Let's add another one for end hover. Let's do, now we need to do interact as well. So if we're actually performing an interaction, let's do begin interaction. Instead of jumping right to end interaction, let's do one in the middle called interact. That'll be important later, and you'll see why. And then finally, let's do end interact. And I'll do one more. We're going to call this transmit value. That won't be clear why we're adding that right now. I don't expect it to be. I'm just adding it now. Again, just as a quick aside, I pretty much never set my interface up this thoroughly at first. Usually building my interface is a very back and forth process where I'm like, oh, you know what? I need a function for this. And then I'll go back and add it and maybe refactor things. But I'm going to try to do this as smoothly as I can. So this should be most of the functionality we need for our interface. The only thing I want to add is that under transmit value in this function, we're going to add an input. So click on new parameter down here on input and set this to value and set its type over to float. And again, you'll see why we add that later. Basically, this is going to take the end value of our slider and feed it over to another object so that we can power it, change things, and so forth. So let's compile and let's save. And now we can go back over to our first person character and start setting up the functionality that we care about. Oh, there is one more thing. And it's so easy for me to forget, and it caused me no end of frustration, but I'm going to try to spare you that frustration. As we perform our trace, because that's, I mentioned earlier, what we're going to do is we're going to trace right down the center of the view to figure out what it is we're looking at, and that will be the thing we're trying to interact with. But check this out. If we go into our first person HUD class, which comes in with the first person blueprint template, take a look. As we draw the location of the HUD, we're offsetting that crosshair by 20 pixels. We're actually sliding it down a little bit, and it's just to make it line up with the projectiles, which we're no longer firing, so let's just delete that. It can go away. Cool. So now that'll put that dead on in the center of our screen. When I was putting this together the first time, I had no idea why why things didn't align. And then I stopped and was like, wait a minute, why don't you just go see where the HUD is? And lo and behold, we tweaked the HUD. So untweak that, and you'll be in a much better position. So I just compiled, saved, and closed because I don't need that anymore. Let's go back over to the event graph inside my first person character, and let's get started. So first off, we're going to begin at the beginning, at begin play. And what we're going to do is we will start off a timer. And that timer is going to say that 10 times a second, we're going to do a trace to look for something to interact with. So let's begin by setting up a timer. We'll drag a wire off of begin play, and we'll say set timer by event, like so. The time will be 0.1, which is 10 times a second. It will be looping. It's just going to keep on firing over and over and over. And I definitely am going to want access to this timer later to turn it on and off or pause it. So let's promote the return value of the timer to a variable. I will call this interaction timer handle. So now I can reach out to the timer and turn it on and off whenever I want to. Now, the next thing is we need to attach this to an event. And you might have actually seen this before, where you drag a wire off this and you do a custom event, which we will call search, or no, let's do trace. That's more accurate. Trace for interactive. And you've probably seen this, right? So now, whenever this timer goes off, it's going to call this event. Something you may or may not have seen, but you should know about anyway, is you can actually snip this wire. You can come over here to your event wire, and you can say, create event. And it creates this fun little node here, and if you choose the dropdown, there's trace for interactive. This is kind of the same thing. It does the exact same job as having the wire connected, but now these can be separated, which can be nice for keeping things tidy. So let's do it that way, just for the sake of learning stuff. I'm going to drag a wire over all this. Let's drop in a comment, and I will call this set up timer for tracing for interactives. I guess that could be worded better, but you get the idea. The point I want to get across is take the time to do your comments early so that you don't get confused if you got to do a bunch of jumping back and forth. So now, when trace for interactive is called, what do we want to do? Well, we want to do a trace. Actually, let's be more specific. Let's do a line trace by channel. And so it's in the live stream. This turned into a joke. It was introducing line trace by Chanel, which is the lamest joke I've told on a video, I think, at this point. And that's a pretty bold statement. But there you are. So there's our line trace. And let's set this up. So the way this is going to work, we're going to trace from the location of the camera straight forward in the direction the camera's looking by around 5,000 units. And here's how we're going to do that. First off, get player camera manager. like so. So now we have the guy that owns the camera. Let's get the camera's location, like so. And while we're at it, let's also get the camera's rotation. Now, the location of the camera is going to be the start of our trace. That's pretty easy. The end point is a little more complicated. We're going to get the rotation of the camera. We're going to get its x vector. We're going to multiply that. So what the x vector is, it's a vector where the line of the vector would be pointing down the x-axis of this rotation, which is the forward axis for our camera, so that's very useful. Let's multiply this by a float to make the line longer. We'll set this to 5,000. Then we will right-click on that pin and promote it to a variable, which we will call interaction distance. So we could change that later if we wanted to. Now the cool thing about setting the value and then promoting it to a variable is you'll notice my interaction distance is now defaulted to 5,000. It's just kind of a neat trick. Now the last thing is we need to add this to our camera's location. So we'll just do a vector plus vector, plug this into our x rotation vector, plug that into end like so, and now we are doing a trace right down the center of the camera. Let's go ahead and comment this. So C, trace down direction of camera by interaction distance. Cool. Essentially, that should be tracing right down the center of the view. Now, what do we do with the result of the trace? Well, let's take this out hit. Let's split it up so we can see all the data that comes out of it. And the thing we care the most about is the actor that we hit. We can assume that whatever it is we're interacting with, it is an actor. So the first thing we're going to do is say, hey, that thing you just hit, is it valid? Now, if you're unfamiliar with an isValid test, use the one with a question mark, not the function call. All this is really saying is, hey, this pin, is there anything in it? IsValid is the same as saying, does this exist? So we're saying, hey, get the actor we just hit. Now, does it exist? Because if the answer is no, then we didn't hit anything. If the answer is yes, then we can proceed. And the way we're going to proceed is, first off, we're going to store the actor in a variable. So let's create that variable. I'll just hit plus on my little variable window, and let's call this current target, and we'll set its type to actor. So type in actor, scroll down, there's actor types. Just click it. Don't worry about which one of these is it. Just click on actor. It's fine. It'll be okay. Now, we are going to drag this out and say set. Now, if this is valid, meaning we did hit something, we did hit another actor, then we want to store that actor inside the current target variable. So now we have a reference to it. Now I want to create another variable, also of type actor, that I will call previous target. This will store the last thing we were looking at before this test. So every time we trace out and hit something, the last thing we traced before is going to be inside the previous target. So now what we'll do is we'll grab this previous target, we'll get it, and we'll say, is current target equal to the previous target? Basically, am I looking at the same thing now that I was looking at just a moment ago? Because if I am, we're hovering on that thing. So let's create a branch. You can hold down the B key and click and create a branch. And we'll plug that into our little equals node like so. So we're doing a logic test saying, hey, are we still looking at the same thing we were looking at the last time? If so, we are now hovering. So here's how this is going to work. Let's grab our current target. We will call hover. Or actually, technically, we're going to call begin hover. Now, what this means is we're not actually going to know we're hovering until at least 0.2 seconds. Well, I guess at most 0.2 seconds into a trace. So if we have to look at something for a fraction of a second for us to know we're actually hovering over it. That might cause a delay. Now, if you don't get how that works, if you're like, wait a minute, what is that? It's because we're doing our trace 10 times a second. The very first time it goes through, previous actor is going to be empty. So this test will happen. It'll say, hey, is current target, this thing that we did hit, is that equal to empty? And the answer will be no, so we won't hover. But then, eventually, the current target will get stored in previous target, we'll trace again 0.1 seconds later, and then they will be equal, and then we can set to hover. So there will be a brief delay on your end. That means you might want to finesse the timing here if you think the delay is too long. But I found 0.1 seconds actually works pretty well. Okay, so next, if these are not equal, then what we're going to do is grab the previous target and tell it to end hover. Because what we're saying now is we have started looking at something else or nothing, just something that is not our previous target, so we should stop hovering over it. Either way, no matter what happens, the last thing we need to do is take our previous target and set it. And when I say either way, that means whether it was true or whether it was false, our last thing is we're going to take our current target and set it to the previous target and store it. So previous target is always being updated last to be whatever our current target was as we tested. So here's a quick pan back. So you can do like a pause if you need to build this on your own, that sort of thing. So there's our trace. And then we do an is valid check from that hit actor. And then we handle our hovering behavior. And I'll do a quick comment on this. Handle hover behavior based on whether we are looking at an actor for 2+ tests. Okay, cool. So now that should all be set. We have a few more things we want to do though. So next we want to start handling interaction. And interaction is going to be based on what the mouse is doing. So if we click on a thing, then we'll be interacting. So due to the first person template, mouse clicks are already attached to the fire command. So I'm just going to use that. So right click and type fire. If you're not doing the first person command, you might actually want to use mouse left button input instead, but I'll leave that up to you. So what we're going to do is grab our current target, and we will call begin interaction when the mouse is pressed. So you click that left mouse button, we're going to begin interacting. When you release it, we are going to call end interact. I should probably rename that too. I don't like that one is interact and one is interaction. That's bad naming. Bonk, bonk, bonk. Let's say begin interact. Cool, I like it. Compile, save, come back over here, and that just updates, which is nice. All right, so when we release, we're going to call end interact, like so. Now there's some other things I want to do as well. I would like our first person character to be able to track when it is interacting. So let's add a new variable of type Boolean, and we will call this, I'll be a little verbose, we'll call this interaction in progress, like so. And this is pretty straightforward. We're going to say when the mouse goes down. Oh, I want to set. Sorry, I just moved over to a Mac, so I'm still struggling with which hotkey is for set and which one is for get. So on the Mac, if you hold down Option, which I think is Alt on Windows, if you drag a variable out, you're setting it. If you hold down Command, which I believe is Control on Windows, then you'll be setting like so. But because I'm switching between platforms right now, I'm still a little fuzzy on all of that. So when the mouse goes down, we're going to set interaction in progress to true. Let me hit Control-C, Control-V, and paste a copy of that node. And when we release the mouse, we're going to set interaction in progress to false. So we're just tracking that. Now we're going to do one more thing that is kind of fancy. We're going to grab that interaction timer handle that we created earlier. So just drag that out and choose get. And we're going to say pause timer by handle when the mouse is down, because while the mouse is down, we're interacting. And while we're interacting, we don't need to be looking for something new to interact with. So we'll just stop looking. That'll be one less process that has to fire. Then when we release the mouse, we can unpause timer by handle, like so. Very clean, very elegant. So let's do a comment. When mouse button is down, set interaction in progress to true, pause timer, when release mouse, 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 opposite. Good enough. That's verbose enough for me. I'll remember what's going on there. Now the last thing I want to do, and this is kind of sort of fancy. I do not want my interacting objects, things like sliders or turn cranks or anything else like that. I do not want them to actually have to tick if they don't have to. And the good news is, if we are interacting with it, then that means some input from the player has to be passed into that object. I mean, you're not moving a slider in a game unless you're actually using a mouse or a joystick or something to move it back and forth. What I'm getting at is that we can use the fact that our input axes are already ticking, and we can pass that directly onto the object that we want to interact with. Now, depending on the type of inputs you need for your game, you might have to be a little picky, choosy about which one you use. If you know it's going to be on a joypad and you've only set up inputs for that, then maybe you grab a joystick axis or something like that. You might even have to eventually get fancy and create a selector for this. Probably not. You could probably pick one that's always going to be there no matter what. Like input, move forward and back are probably going to be pretty universal. But what I'm going to do, just because it's nice and tidy, is I'm going to grab our mouse input and grab our turn axis. It doesn't matter which one of these axis inputs you grab, because the cool thing about axis inputs is that you can pretty much guarantee that they're always being pulled. You always need to know the axis values of your inputs, so we can just turn that into an event that we can use. And here's how. Sorry, I've clearly been a little caffeinated. Thank you very much for bearing with me. Let's go to interaction in progress. We're going to get that, and we're going to branch off of that. So an if statement, essentially. And we'll just connect this to our input axis for turn, which is going to be taking place essentially on every tick. Now, I do not know if it happens before or after our object would normally tick. If you care about such things, which you may not, it's also worth noting that for something like an interactive slider in a game, you probably don't care about tick accuracy. If you care about tick accuracy, speaking just as plainly as I can here, if you care about tick accuracy, you should probably be doing whatever it is you're doing in code anyway. So, well, if we are in the process of interacting, then we want to get our current target. So we'll drag that out and say get, and we want to send it the interact message. Boom, like so. That's all there is to it. And let's go ahead and comment that. If interaction is in progress, actually, let's be a little more programmery about this. If interaction in progress, you could leave it at that, but I'm not gonna, is true, then send interact to current target. Which that should be readable, but you know. Okay, so there we go. I think with that, we have all of the functionality that our first-person character really, really needs. Let's compile, let's save, so we're good there. Let's now begin creating our new slider blueprint. So I'm just going to right-click here in my content browser. Let's create a new blueprint class. Let's set its class to actor, and we'll call this BP_slider. We'll open this up. Now, let's say I'm going to add a couple of components to it. Let's just do static meshes, static mesh, which we will call slider. And then we'll come over to its static mesh property, and we'll set this to the slider, sn slider 1. Perfect. Let's add another static mesh component, which I will call slider base, and I do not want it to be parented to the slider. That is bad. So let's just drag that up to default scene root and choose attach. So now they're no longer parented to one another. That'll be important. With our slider base component, slider based static mesh component selected. That was a mouthful. Let's set our static mesh property to the slider base, like so. Awesome. Now they're kind of penetrating through one another, which is rude. So let's grab the slider base and we'll slide it back about 10 units by default. There's a little gap here. If you care about that, then lower your grid snapping and fix it, but I don't care, so I'm not going to do that. Cool. So now we've got our two meshes in place. Now there's a few more things we need to do. We need to set up some variables for data that we care about. And the first two things we're going to add are some states or Boolean values that will be either true or false. The first one of these is hovered. This thing should know whether or not it's hovering right now or whether something's hovering over it. So we'll just call that hovered. We'll add another one called uh, interacting. Actually, I should fix my tense. I think I did that twice because it's wrong in my notes. We'll do hovering and interacting. That sounds better because that means we're in the process of being hovered and in the process of interacting. Now there's two vectors I want to add as well to represent the start and end of the slider. We'll call those start. Let's come over here to the variable type on the far side. We'll set this over to a vector. And we'll add one more, which we will call end. Compile, and then jump over to your default value for end and set its x value to 200, which should be approximately the end of the slider. We can confirm that, though. With your end variable selected, turn on instance editable, turn on show 3D widget, compile, save, go into your view, and I don't know, let's just pick on this little wall right over here, and let's drag the slider onto it. And it's facing entirely the wrong direction. So let's rotate it 180 degrees and let's slide it out from the wall. Haha, perfect. And I'll center it up because if I don't, that'll start to make my eye twitch. Okay, so there we go. And you can actually see our end variable shown here by the little 3D widget. It is pretty much at the end of the slider. You can tweak that if you wanted to, but I think it's fine where it is. Okay, so now back over into our slider. The next, probably most important thing we're going to do that I need to talk about for just a second is we're going to go under class defaults and we're going to turn off start with tick enabled. It's worth noting all of the blueprints you create by default have this enabled. It's just how blueprints work. We do that because we expect people who aren't super used to blueprints or maybe aren't super used to scripting at all can connect something over to their tick event and have it work. The thing about it is, though, as long as that checkbox is true, you're always ticking, even if nothing is connected to the tick event. It's more of a, here's how we make this nice and usable, more than here's how we make this super efficient. Now, there is a way to turn this off for all blueprints you create. I believe it's in any setting. I don't remember what it is off the top of my head. It's been a long time since I had to do that. A lot of studios actually do that for all of their blueprints, so that whenever they create one, tick is automatically off. But in the meantime, just go ahead and make sure if you don't need to tick, and probably most of your blueprints should not need to tick, that you just turn this off and leave it off. Okay, cool. Now, I've had my little lecture about that. Let's start building up our hover behavior. That's going to begin in the construction script with us setting up a dynamic material. So let's grab our slider from the components list. We'll drag that into the grid, drag a wire off of that, and just type the word dynamic, and you should see create dynamic material instance. For those of you who are unfamiliar with this, all this is going to do is take whatever material is already applied to this static mesh, make a dynamic version of it so that we can adjust any parameters inside of it. If I double click to open up the material currently applied, which is orange, here you can see the material definition, and it has a named parameter already built into it called color, which is super convenient. We should just make sure that we remember what that name is because we're going to need to reference it later on. Okay, so now we have a dynamic version of our material. Let's store that in a variable so we can talk to it later. I'll right-click on this pin and choose Promote to Variable, and let's give it a descriptive name. We'll call this Slider Dynamat. The name makes me happy. It reminds me of Photomat, and I'm old enough to remember what those were, though I never got to actually use one. Okay, so cool. I think that's all we need to do there. So now we need to start managing what that hover color is going to be. And in order to do that, I'm going to go over here to my functions list in the My Blueprint window and click on plus function or new function, and we'll call this manage hover color, like so. Now here's what manage hover color is going to do. It's going to grab that hovering variable we set earlier, so we'll get that. Now we're going to create a branch off of this, like an if statement, for those of you who have ever done any scripting. So we'll say if we are hovering, if we're in the process of hovering, then I want you to do one thing. If we're not in the process of hovering, we've stopped hovering, then do something else. And this is going to be really straightforward. We're going to grab a reference to our Dynamat, slider dynamic material, thank you. And we will say set vector parameter value, because a color is a vector. It has 3 values, R, G, and B. Technically, it has a 4th one for alpha, but we're not going to split hairs here. So let's just connect this up. Now, what is this color going to be? Well, first off, let's do the parameter name. We know that was set to color with a capital C, though we're not case sensitive. It's fine. We'll just type in color, and that should work. Now, we need to define what this color is going to be. And what I'm going to do there is come over to my variables list, and we're going to add 2 new variables to hold these. The first one we will call hover color. And we will set this, so we have to search for this. We'll set the type to linear color. So just type linear, and there you go. And then we're going to add another one called non-hover color and compile. Now, for the non-hover color, check this out. I jumped back over to our material. If you don't remember how to get to that, go back over to your slider and just double-click its material, like so. And we'll double click to open up the color picker, and then I'm going to grab the hex linear value. You can really grab either one, the linear or sRGB value. It doesn't matter. Just be consistent with the one you choose. Let's hit Control C, or Command C in my case, to save that. Close out of here, go back over to our slider. Here in non-hover color, we will open up the color picker for the default value and paste this into hex linear, and there we go. Okay, so now that we've got that going, let's just take hover color and plug this in. We need to set hover color as well. So let's just set this to an internet lime green obnoxious color, like so. So now what we're doing is saying if we're hovering, we're going to set the color of this slider over to green, like so. I don't have to set alpha up, but it's going to drive me crazy if I'm not consistent, so we'll set that. Now, if we are not hovering, your instinct might be to do this. You could grab the slider Dynamat, so Control C, Control V, and plug that in like so. And your instinct might be to say, all right, well, if we're not hovering, let's just take the non-hover color and plug it in like so. And that would be a good instinct, but we are going to get fancy. One of the problems we were able to identify with the slider back over in content examples, which is over here, is that even as we are using it, it stops with the hover color if the mouse moves off of it. And I would like to prevent that. So let's do that. So jump back over to our project. And what we'll do instead, let me actually snip this out. Just hold down Option or Alt in your Windows case, and we'll snip that. And we'll say, if we are in the process of interacting, so we'll get interacting, just drag that in, and then hold down B and create a new branch. So if we are not hovering, see if we're interacting. And if we are not interacting, then set the color back to normal, back to the non-hover color. So hopefully you see how that works. Now, we do have to set up the color itself, so here's how we're going to do that. Let's go back out to the event graph. And I'm just going to kind of, here, you know what? Let's just clear these out. We don't need them. So here in some blank space, we will right-click, and, well, I'm not going to be able to do anything. We have an important step that I skipped that I'm going to do now, and that is that I need to implement that interactive interface that we set up earlier. So let's go over to our slider, let's go to Class Settings, and over here under Implemented Interfaces, let's click Add, and let's there's interactive right there. We'll click that. Make sure you compile, because until you compile, that means nothing. And now that we've done that, we can right-click and we can say hover, and there is our begin hover. Oh, wrong one, sorry. Let's try it again. Hover. Now we want the event version of this. So we want event begin hover, and then right-click, type hover again, and we want the event end hover, like so. So now what are we going to do? So what we'll do is we'll take our hovering variable and we will set that based on whether or not we receive either one of these events. So if we receive the event begin hover from the interface, then we will set hovering to true. And I'll hit Control C or Command C, whatever, and we'll paste this down. And if we receive end hover, then we'll turn hovering off. Now, either way, whichever way this happens, we're going to call manage hover color next. like so. And really, that's all there is to it. So now let's go ahead and throw a comment on this. Manage hover color based on hover events from interface. Cool. And that seems to be working fine. We could test this at this point, I think. So let's just hit play. And oh, wow, that's like a tiny window. That's big thanks to Mac for having like a giant retina screen. So here you can see that as I mouse over the object, it turns green. I'm sorry, that's a ridiculous size. That's just too small. So let's do it from out here. Okay, cool. So boom, as I mouse over, it's green. Stop mousing over, and there you go. So very cool. Now another thing that you're gonna have to take my word for is as I click and hold the mouse button. So like here, hang on. I'm gonna hold down the mouse button now, and I'm still holding it down as I move around. Notice the slider stays green until I let go of the mouse in 3, 2, 1, pop, and it turns orange again. So now we've already found a way to be better than the original slider because we're maintaining that hover color the whole time we're interacting, which is very cool. Okay, so now we need to actually set up some interactivity. So let's go back into our slider. And the next thing we'll bring in are the interact events. So let's right click and type interact, and we want event begin interact. Let's do it again, right click, type interact, and we want event end interact. So what are we gonna do with these? Very simple. We are just going to, I chose correctly. This option on Mac, it's Alt on Windows. I'm drilling myself on that as much as you guys. So on begin interact, we're gonna set interacting to true. And I'll just copy paste. On end interact, we're gonna set this to false. That is all we're gonna do here. So let's drag these out, hit C to create a comment box, and we'll say, what do we wanna say here? It's just handle interacting state based on events from interface. All right, cool. Excellent. All right, so that is all working, but now we need to create the interaction itself. So earlier, as a refresher, in our first-person character, we are intercepting these axis polling ticks, and we're sending these over by way of the interact message. So let's go back over to our slider. Let's right-click, and let's just search for interact again. And now we're going to create an event for interact. So whenever we receive interact, we want to do, well, essentially whatever we would do on a tick, which is update the position of our slider and then send out its value. So calculate a value for it and send it out. So to make this happen, let's do this. Let's create two functions. So over here, my functions list under my blueprint, click plus function, and the first one will be move slider. All it's going to do is just move the slider, keep it in the right position, and that is it, and that is all. The next one, we'll create another one right under that called solve and report value. And you could make this 3 where it's like solve is its own and then report is a separate function, but report is so basic, it's like just a couple of nodes, so I don't mind those being kind of collapsed into one. In fact, the whole thing could be one function if you wanted to, but if for some reason like the motion was wrong for some reason, I'd like to be able to narrow it down right to that location. Now, before we populate these two functions with any functionality at all, let's go back over to our event graph, and on interact, I'm gonna do a sequence. I'm just gonna, by the way, I made that manifest out of thin air. If you're unfamiliar, just hold down the S key and click, and that'll make a sequence node. So this is just a list of things that are going to happen. The first thing we're going to do is move the slider. And then the second thing we're going to do is solve and report the value. So that's pretty straightforward. Interact functionality, which is kind of like an on-demand tick from axis polling. So there you go. So cool. Technically, this is working. It's just not doing anything. Whenever we receive interact, something should be happening. But right now, we haven't told it to actually do anything. So we're going to start by doing the behavior for moving the slider. So we'll jump into our move slider function, and let's start populating this. Now, here's how this works. What we had before in the original slider in content examples is a whole bunch of fun math to try to figure out where you think you want the slider to be based on some mouse input axis events and things like that. What we're going to do instead is we've already performed one successful trace right down the center of the view. We're going to do another one. We're going to do our own line. We're not even going to do a trace. We're going to draw a line from the camera straight down the direction it's looking. And we're going to check to see where that line intersects with a plane. We'll define that plane based on the location and orientation of our slider. Think of it like the backboard on a basketball goal. So we're just going to have a great big invisible plane that is parallel to our slider, and we're going to perform line traces, in essence, against that to find a point. Once we have that point, we can figure out the shortest distance from that point to the slider itself. And we can do this all using math functions that already exist in the engine. If that sounds confusing in any way, don't worry, just follow along and it will all become clear because I'm going to demonstrate it at every step of the way. So the first function we're going to leverage from inside the engine itself is line plane intersection, and we want access. We want access to the origin and normal of the plane, so we'll choose that one. Boom, like so. Now, we need to figure out what the start and end of the line is, and the plane's origin and the plane's normal. Now, here's the fun thing. We've already done this once already over in first-person character. We created some math based on the camera's location and rotation to perform a line trace. Essentially, all we did here was draw a line. We then fed that line into the line trace functionality. Well, I liked that math, so we're just going to grab it, we're going to copy it, jump back over to our slider, and we're going to paste it in right here, or I'm not, and it's just going to move windows on me. So let's try that again. Thank you. I must have hit a really weird key combination that jumped me around a little bit. Okay, so we copy pasted. Now there's a catch to this that actually bit me in the live stream version of this. It's not going to bite me this time. Notice we pasted the interaction distance variable and it's gray. That means that variable does not exist over here in this class. So we can right click on it and choose create interaction distance. Technically you could do this as a local variable, but I'm not gonna. So it was created as a regular variable. Now compile and notice this one has a default value of 0. That's bad. Set its default value back up to our standard 5000. Okay, so now the camera location becomes the line start. The end result of all this math, where we take the direction the camera was facing, we get its x vector, which is essentially a line in that direction. We multiply that by 5000, and then we add that to our camera's location. That becomes our line end. Same thing we did with the trace. Now we need to solve the plane. The plane is actually pretty easy. All we need is to say get actor location for this slider, because it's already set to self. So this is the slider's location. That can be the same location as the plane. That's perfect. And we can say get actor rotation. Now, we got to get a little fancy here. We need to turn this into a normal. And if you're unfamiliar with what that means, a normal is a line that comes out the front of a plane that defines the front of it. Consider a coin. Coins tend to have like a heads and tails side. If you could take a little tiny invisible line like the size of a hair that stuck out of like George Washington's left nostril on an American quarter, and if you're not from the States, then that's on the head side. Don't grill me on this too hard. That little hair, that line sticking out of the face of the quarter would essentially be a normal. What we have is we have a rotation. We need to figure out what the front vector is for our slider, and then we'll rotate it by our actor rotation. Let me show you. I'll go back over here to our viewport. I'll select any part of my slider, and you can see, or I think you can see, that the y-axis in green is pointing out of the slider. That would be a perfect normal for our plane. But the problem is that we need to make sure we orient that line by whatever rotation we give this slider. Because we could rotate this slider. It could end up, in fact, the one we have was already rotated 180 degrees around Z. You could be putting it on a wall, on a ceiling, on the floor. So what we'll do is over here in Move Slider, we will say rotate vector, And the vector we want is the y-axis, which is 0, 1, 0, and we're just going to rotate that by the actor's rotation. Plug that into the plane normal, and we're essentially good to go. We could line this up. Let's throw a comment box around the whole thing. Find a point. Now let me write this a different way. Find the line plane intersection from a line from the camera. Hang on. Sorry, I'm going to be really picky about my wording. Line from camera direction to plane defined, I can type, I promise, defined by the slider. Cool. So now that makes sense for later. But to make sure this is working the way we think it should, let's do a quick debug test. So we'll right click and we'll say draw debug plane, like so, and connect this into location, and we'll, oh, that's not what I want at all. I got way ahead of myself. I'm sorry. We want to do draw debug point. Sorry, I kept thinking plane, and then just, you know, that's how brains tend to work. So, or at least my brain. So we'll take the intersection point that we've already solved. We'll plug that into position on this draw debug point. We'll connect this to the input for our execution of our function. Let's take the color and we'll set it to red. You can make it any color you want. I'm just going to make mine red. We'll set the size to 10, and we'll set the duration to 0.1, so it's going to live for 1/10 of a second. This is firing off on every tick, essentially. So that means we're probably going to have a little bit of a trail, but I'm actually okay with that. Now let's test this. So we'll hit play, and come over here, and oh, check it out. If I mouse over, click the mouse button, and start to drag to form an interaction, you can see we have a dot on a plane. Pretty cool. Now, if I kind of move sort of in a direction, sort of aiming down this, you can kind of visualize it is following that plane. It kind of recedes out into the infinite, or at least to 5,000 units along this direction. And same if we go on too far in this direction. So there is a plane there, but it's an invisible plane, and that's fine by me. Cool, so that's working. So now let's go back into our slider, and from this point, we now need to solve the nearest point from this point that is along a line. So let's come over here. I'll just create my function first. So closest point on line. There it is right there. So what we need is a point, and we need a line. The point is easy. We're going to define that using the point we just solved on our plane. Now we need to define what our line is, and we will do that by grabbing our slider. And actually, I think we can just do that from the actor itself. I think that'll be fine. So let's just say get actor location, and that will be the line's origin. So that's where the line is starting. But now we need to figure out the line's direction. So this will be get actor rotation, because this is all in world space, and the actor could be rotated in any which way. So now let's do the same thing we did before. We're going to rotate a vector. Now, what axis do you think we care about? If you don't know, or if you're confused, just come over here to the viewport and double check. And it looks like the x-axis actually points down the slider. So that's exactly what we want. So let's go back over to move slider. And we'll just set this to the x-axis, which is 1, 0, 0. And we will rotate that by the actor's rotation, and that will be the line's direction. So that's pretty easy. So now let's debug this as well. I'm going to grab my draw debug point here. Let's just copy paste it. But this time we'll set the color to like super obnoxious green, because it represents the slider, or where the slider wants to go anyway. Now, quick note about these draw debug points. Notice these are flagged development only. That means they're going to work in the viewport while we're still testing, but once we cook out our project in a like a shipping build, like basically when the game's done, these will no longer function. So generally, for sake of cleanliness, I tend to snip these out entirely when I'm done with them, but they should just work like pass-throughs if you were to leave them in for shipping. It should be okay. So now let's plug our position in here, and technically this should just work. Let's go back out and test it. So again, nothing happens if we're just mousing over. We just get the hover behavior. We have to mouse over the slider, hold down the mouse button, and check it out. That green dot is now a target location for where we want the slider to go. How cool is that? And even if the problem, actually the problem we're trying to solve, if it's not abundantly clear, is if I was trying to drag this slider. Now, it's a pretty fat slider, and that's great. I could probably keep my mouse right on line with it, and that's fine. But if I couldn't, or if I was moving really fast, it's possible that my mouse might come way up here or way down here or fall off the axis of the slider, and I still want to know where that slider puck should go. So that's why we're doing all this. It'll also keep us from being able to really ever move the slider too far from where the mouse tells it to solve, which was a problem we identified with the content examples version of this slider. Okay, well, I didn't want to do that. Let's hit escape. Let's go back over into the slider. And let's put a comment on this. Find closest point on slider. We can be kind of technical here. Slider from point on plane. Cool. So now we know exactly where we want the slider to go. The question is, how do we get it there? And this is actually super simple. We're going to use a vector or v-interp2. Now, if you're unfamiliar with what interp2 does, it takes an incoming value and tries to interpolate it to a target value. There is a really cool blog post over on the Unreal Engine blog written by Jeff Ferris, actually a few years ago, that explains how these work in really good detail. So if you jump over to our blog and you search for interp2, it's actually pretty easy to find. If you've never used these before, I highly recommend you read that blog post. It's super amazing. So now, let's set this up. This requires us to have a current and a target. So let's right-click on the current pin. We'll promote that to a variable, which I will call slider goal. We need to give it a target. The target is going to be whatever we just solved from all of this math. We need to give it a delta time. That's easy. Just right-click and type world delta, and you'll get the world delta seconds. That's the amount of time it's taken to go from one frame to the next. So it's usually a very low number unless you're hitting terrible performance values. And then we need to give it an interp speed, which I'm going to hard code at 5. But you might want to test this and see if you need your slider to go faster or slower. Now let's take slider goal, drag this onto the return value, because the whole thing is that you're constantly updating this value. So it is connected to both the return value and to current. That's how these work. We'll connect its execution pin, like so. Now this is giving us a goal to move to, but we haven't really done any motion yet. We have some more work to do. Now here's a quick side note. All of these calculations for finding this point on a plane, finding the point from that on a line, these have all been done in world space. And what we want to do is actually move our slider in its own local space. And there's a node specifically to handle that transition. It is called inverse transform location. Now what this does is you feed this a transform value, which is position, rotation, and scale, and it'll create the inverse space. If you feed this local space, it'll output world space. If you feed it world space, it'll output local space. So that's what we want to do. We've already got world space. We're going to plug that into location. Now we're going to just right click and say get actor transform. And the result is now no longer in world coordinates, it's in local coordinates, which means like if we moved it 1 unit down X, it would just slide over 1 unit, as opposed to setting it to an X value of 1, where it would go to the world's origin plus 1 unit in X. For a real quick crash course in spaces, if you don't already know how those work. So let's put a few comments in here, just to be clean. So here we are interping, no, it's terrible, interpolating to goal location, low action. Okay, and then comment inverse to local space. Awesome. Now, the next thing we're going to do is we're going to clamp this value. This will keep the slider from sliding off into infinity. We want to lock the slider so it can't go any farther than our predefined end location. We basically want to keep the slider moving between the start and end variables we defined earlier, and here's how we're going to do that. First off, let's grab our end result up to this point, and we're going to break it apart. So it's a vector. We're going to separate it into x, y, and z individually. Let's grab our start. Let's grab our end. So we'll get both of those. I'm going to just hit Control-C, Control-V, and paste these break vectors in and connect them up because we're breaking all of these. And here's how this is going to work. Let's start with x. So we'll take x, and we're going to choose clamp float, like so. And we're going to clamp this value in x to between the clamp x for start and between the start x value and the end x value. Let me say that again. I'm going to clamp our end result x value between the start x and the end x. Now let's grab this clamp float and we'll copy paste this a couple times as well. We'll take our outgoing value for y, plug that into value, start y into min, end y into max. Our end result z will go into our clamp value, start z into min, end z into max. It makes kind of a neat little pattern if you line it up right. Isn't that cool? Okay, so even cooler if you get really careful about how you line it up. All right, so now we need to turn the end result of all these and make them into a new vector. So we'll just drag one wire out and choose make vector and plug x into x, y into y, z into z, and so forth. And now we have a new end result. Now, let me go ahead and move these out and comment them. Clamp value to stay within range of slider. Now, you might be asking yourself, why are we clamping now? Why couldn't we have clamped way back here before we did the v interp to and all of that? Well, the answer is we totally could. The problem, though, is that if we had done that, then the v-interp would actually cause us to slow down as we hit the end of the clamp, because that's how interps work, as you're going to see. By clamping after the fact, we're able to kind of slam the slider all the way to its start and end, and the entire range of motion just feels more satisfying to use it. So we're going to set it up this way. Now, we finally solved our value. We got our point on a plane. We use that to figure out the closest point on a line from that point on a plane. We are smoothly interpolating a goal location to that. We are switching that over into local space. We are clamping that between a start and an end, which are also in local space, which you can confirm here because end is just 200, 0, 0, and not some weird world coordinate based on where the slider is. And now the last thing we need to do is grab our slider itself. So we'll just drag that into the view, and we'll say set relative location. And we'll feed it this end result. That's all. Now we just need to really connect this all the way up to our other execution pin. And if you wanted to be really nice and neat, you might want to set up reroute nodes. If you're unfamiliar with those, you can just right click on any wire in Blueprint and create a reroute node just to kind of line things up, make it a little neater. Now we should be able to test this, and there's going to be problems, but I want to test it anyway. If we come back out to our first-person example map, like so, let's hit play. Oh, so it's working right now. Actually, this is working really well. But there was a problem, like right there at first. Did you see it? So let me first off set my play to go from the current camera location. Let's try that again. Notice when I first try to move it, bam! It jumps to this terrible location and then it comes back down. And that's a problem. Why is it doing that? Well, it's doing that because the initial value that the slider has is not the same as where the slider's actual position is. So it's popping to a new default location. To solve this, to kind of shore this problem up, we're going to create an initialization to deal with this. So let's stop playing. Let's go back over into our slider. Let's create a new function called initialize slider. And what this is going to do is set up the initial location for the slider and make sure the slider's goal, that default value that we're interpolating, we're going to make sure that that has a nice value. And here's how it's going to work. We will, first off, grab the slider itself, and we're going to set its relative location somewhere in between start and end. And actually, right now, the problem is we don't even have a default value for the slider. So let's create a new variable. We'll call this default value. Let's go over to its variable type. We'll set this over to a float. Now, I'm going to put some restrictions in here. We'll set the slider range between 0 and 1, and then value range also between 0 and 1, because that's all I ever want the slider to have is numbers between 0 and 1. Other things that implement the slider can take that number, multiply it by an end target value, and thereby kind of massage the numbers into whatever they need. So now let's get start, let's get end, let's do a lerp between two vectors. So we'll lerp between start and end, and we'll use default value for the alpha. So right now we know our end is 200, 0, 0. If we set default value to 0.5, the end result would be 100, 0, 0. So we'll plug this into our new target location. Then, last thing, we're going to get our slider. We're going to get its world location after it does this. So this is actually kind of cool. We're going to tell it to go to a relative location. After it's done with that, we're going to get its new world location, and we're going to set this as the new slider goal, because that's the number that was causing it to jump. This was defaulting to 0 in world space, so that was causing the end result to try to basically slide all the way to the world origin and then have to come back. So what we're doing instead is saying, hey, go to a nice clean default location. Let's get the world location of that, and that's going to be our new start goal. So now, with that done, we need to make sure we call this. So let's go back out to the event graph. Way up here on begin play, which I haven't even used begin play. That's amazing. I totally forgot about that. So let's right click and we'll set up begin play. We will call initialize slider. So that's pretty handy. Like that means everything should be nice and smooth. So let's test it. Let's come back out here to our map, hit play, and whoop, check it out. No wacky jumps. Now, something we can do, let's try this out. Let's do something real fast. Let's go back into our slider. Let's take our default value and let's make that instance editable. I refer to that generally as public. We could be really fancy too and give it a tooltip. This is the default value for the slider. Cool. So now I'll compile and save. I think I added that to totally the wrong thing. I totally did. That's okay. Let's just grab all of it and cut it. Come back over here to default value and just paste that into the tooltip. Jeez. It's going to be that kind of day. Okay, cool. So now you'll notice the little interactive icon turns green to let you know that you gave it a tooltip and that you're behaving. So now if we come back out here to our slider, if we select it, it now has a default value that's exposed. We could set this to like 0.25. And now when we hit play, you'll notice it's already a quarter of the way along. And everything just works. Now something I haven't done, I guess you could probably call this off the construction script, but I wouldn't necessarily trust that, because if this is attached to other things, you can't by default call the construction script on those other things. You could write like a blutility or a blueprint utility to update all of that. That's a little bit beyond our scope. We're going to leave this relatively simple for now. Okay, but to make sure it at least works at game time, so when you actually hit play, you want everything to be at their default and ready to go. What we'll do is inside our slider's initialization, the last thing we will do is we will call, well, move slider should already be, that should already be fine. We shouldn't really need to call this. We'll just call it as a fallback just in case, but we'll also call solve and report value. So this means at begin play, this will send the current value of the slider out to anything that it's attached to, like lights or whatever else you happen to be controlling by way of a slider. Okay, so cool. That should all be good, but we can't test it until we get some interactivity going. So let's work on that. This is actually pretty straightforward as far as these types of things go. Let's go into solve and report value. The math here is actually pretty easy relative to what we've been doing up to this point. How have I been in terms of commenting? I've been good here. Initialize slider. We should probably throw in some comments here. So I want to be good about good practice. So we'll grab this section, lerp the slider to default value between start and end. And then find world space location, send to slider goal, and then basically update everything attached to the slider. Cool. All right, so now we can move on to the solve and report function, which currently does nothing, which is why our slider doesn't do anything other than slide back and forth and look pretty. Now, this is, again, pretty easy. The first thing we're going to do is get our slider, and we're going to figure out where it is between the start and end points. Now, in order for that to make sense, we need to know how far it is from the start. So let's begin by getting its relative location. So drag out a wire and say get relative location. And then we will subtract from this the start. So this essentially, if we take this vector and get its length, so get vector length, actually, thanks. I know where my delete key is. Let's just type length. There you go. Vector length, thank you. So getting the vector length, this float value is telling us how far away we are from the start of our slider. It's also kind of another way of saying here's kind of where we are along the slider. Now next, we need to basically normalize this value to 0 and 1 based on the length of the slider. So let's take start and end, because remember, end is currently like 200, 0, 0. We're going to subtract start from end, like so, and we'll get that vector length. So I'm just going to copy paste the vector length node so I don't have to try to find that again. And now we will take where we are and we will divide it by the overall distance of the slider, which is, so this is basically saying, here's how far along we are along the slider. Here's how long the slider is. By dividing the two, we get a 0 to 1 value, which represents how far we are, or what the final value of the slider should be. So let's promote this to a new variable, which we will call value. We'll connect that up like so, and that's working great. And now we need to report this out. So we need to build a reporting system, which really doesn't exist at all right now. Over in our interface, we added a transmit value function as a refresher, and we gave that a value input. We're gonna need that, but I want to be a little fancy, and I want to give us the ability to connect multiple values or multiple actors up to this slider, so it could function on different things all at the same time. So let's give that a shot. So let's see here. First off, we need to create an array of all of the things that this slider could be affecting. So let's create a new variable, which we will call driven actors. We'll come over to its variable type, and we'll set its type to, you guessed it, actor. Just click on actor, don't worry about object reference, it's going to default to that anyway. But then, right next to variable type, there's this tiny little icon to change what type of container this is. We're going to make this an array, which is essentially a list of things. And then we're going to make this instance editable or public, which we could do here with a checkbox or here with a little icon in my blueprint, whichever way is fine. Let's give it a tooltip. So list of actors this slider is controlling. And we'll compile. Now, here's our list of actors. Let's get it. For each one of these that we have in the list, for each thing in the list, we want to transmit out that value. To do that, we use a for each loop. So let's drag a wire from our array, type for each, like so. Connect this up. And each one of these that it finds, we will transmit value. And the value we will send is this value we just solved. Now, if some of you in the crowd are like, wait a minute, Zach, aren't you performing a loop on something that is essentially ticking? Aren't you performing a tick on a loop? Isn't that inefficient? Well, the answer is kinda. Yes, we are performing a loop on something that is ticking. That has a cost. But at the end of the day, if we have, no matter how many things we have attached to this slider, we have to send this value out to all those things on every tick. There's no other way to do this. So this is one of those cases where, yes, we are looping on tick, but we're trying to be as responsible as we can. We have to in this case, because we have to get that information out. It would come with the understanding that the more objects you add to this slider, the more it's going to cost to use. A few things should be fine, and you probably don't want to drive 100 different things on this, but if you did, you might actually start to notice that you've got a lot to loop through on every given tick, and you might start having to rethink your strategy. For now, though, this should be fine. So we're transmitting our value. Everything should be going fine at this point, but it'd be good if we tested it. So let's do a print string and connect this up, and we'll just fire our value right in like so. Sounds good. Compile, save. Let's jump back out to our scene and test. Oh, it's not actually being called. Why? I might not have actually hooked it up. Let's double check. Back into the slider. Solve and report value is doing a thing. It's assigning all of that. And then it's calling print string. That should be good. So let's come back out here to our event graph. Oh, you know what? I might know what this is. I think I know what this is. On interact, we are sending out move slider, then solve and report value. No, that looks like it should be working. Bonk. But it's not actually transmitting anything out. Well, that's interesting. So let's figure that out. It's probably just something dumb that I overlooked. That is the story of my life. So solve and report. This is being called. Now, one thing we can do is just make use of Blueprint debugging. So let's come over here real quick. I'm going to go to my play dropdown. Let's go to advanced settings. And currently, this is set to a default width of 1280 by 720. Because I'm on an iMac that has a ridiculously high resolution, that's crazy. So let's set this to 1920 by 1080. We'll set our little preview window at 1080p. And that should be better. So we'll close this. Let's go ahead and jump back over here and play from inside here. And that didn't help at all. Oh, actually, it might have. It probably did. Okay, so now what I can do is we can move this up here, and when I play, cool, it's being called. Oh, obviously, the here's the problem, derp, is that the driven actors is empty. So that for each loop is being called 0 times. Okay, I should have known better. So what I'm going to do real quick is we'll snip this out, and then as soon as we get done setting our value, actually, let me just delete this. Delete this. I feel so silly. But that's why we do these live, right? Because you'll probably run into something silly like that and be like, oh, man, wow. I'm dumb. So we'll plug this in like so. So now we're just taking that value, plugging it into a print string, and then we'll continue. So now when I test, everything should work, and everything should be happy. Notice it already just sent out 0.25 at the beginning of the game. And there we go. So there's 1, and there's 0. And all the numbers in between. It's beautiful! Ha-ha! Okay, cool. That's excellent. So now, as a bonus, which I probably wasn't going to originally do in my live stream anyway, let's connect this up to something. I'm going to delete out my debug stuff. I'll leave the debug points in. They're fun to look at. They make me happy. Though if this were like a real demo, I would definitely remove those. Technically, we're done. You have a functioning slider, but now let's show you how to use it. So I'll go back out here to the content browser. Let's right click and we'll create a new blueprint class based on actor. And we'll call this interactive test, like so. And let's open it up. Now I'm going to keep this like really, really simple. The simplest thing I know for showing this type of thing off is like doing the old point light example. So create a point light. We don't have to rename it; it's fine. But actually, let's be a little bit fancy. You guys can always fast forward if this is boring to you. Let's grab the point light and let's set its color. So we'll set the light color. First off, let's get its light color, which is currently just F, all the Fs ever. So that's easy. So let's do this. Let's make a new variable called light color. Let's go to its type, and we'll set this to a linear color, like so. No, not linear interp, but linear color. Clicked the wrong thing. Let's compile. Let's set this to a default value of white, just like we have here. And we'll plug this into the new light color. Connect this up. But then we're going to take our light color and we're going to make it instance editable. Click that little eye icon or the checkbox. And we'll say, this is the light color. The name kind of says it all. Okay, cool. So now we can edit the color of the light on each individual instance. The only other thing I can think of... Nah, let's keep it simple. I don't want to get too carried away. So now, let's just do this. First off, let's come over here to our class settings. Let's implement the interactive interface. This is going to receive function calls from that interface, so it has to implement it. Remember, callers or senders do not have to implement an interface because anybody can send through an interface. Receivers, those who are receiving that data from an interface, they must implement. So we'll implement the interface, make sure we compile, come out here to a blank spot, and let's just attach something to transmit value. So on event, transmit value, there's our incoming value from the slider, which is great. Let's grab our point light and let's set its intensity. And what are we going to set it to, they asked. Well, let's do this. Let's do a lerp. So notice I dragged a wire backwards there. And if we create a lerp, now it's lerping between two values given an alpha. We'll use our slider's value to drive the alpha. We'll leave A at 0, set B to 5000, which is the default brightness of a standard light. So now that slider value is being blended between 0 and 5000. But let's test it. So let's come back out here to our scene. Let's drag this into the world. Oh, it's got a light. That's cool. And let's give it a color so we can differentiate it. We'll make this one like, oh, there you go. There's a really cool, obnoxious color. And just for the fun of it, let's make a copy of it. So if you've never done that before, on a Mac, that's drag with Option held down. On Windows, that's hold down Alt and drag. Let's give this another terrible color. This will be green. Now over here on our slider, check this out. We have our driven actors array. I can just hit plus. Actually, let's hit plus 2 times. And then next to each one of these, I can just use my eyedropper tool. So pick from scene, click the eyedropper, and we can add this light. And we can click the eyedropper and add this light. And let's hit play. Ooh, I think it's already working. Oh, or it's not working at all, and it's totally broken. So let's figure what out. Oh, what just happened? So let's see. Oh, that's totally the wrong instance of Unreal. So let me hit escape. Let's figure out why that's not functioning. It's probably something really, really silly. It's usually how these things tend to go. So we compile and save here. Let's make sure that this guy is actually receiving transmit value. Because if it's not, that would be our problem for sure. Yeah. No, that's good. Okay. So let's hit play and we'll move this out of the way. And okay, so this is focusing on interactive test 2, which I believe is our green light. Oh, so it's totally receiving values. That means the light color is probably breaking somewhere along the way. or this intensity value. Well, you know what? Usually when I'm debugging, I use print strings everywhere. So let's just print string. We'll have this print whatever its value is, and then just play. It's receiving 0. It's totally receiving 0 the whole time. So as we, essentially what's happening is our value is always receiving 0. That means something is misconnected over here. There it is. There's my problem. So by a little bit of debugging, I never plugged my value into transmit value off of my loop. Essentially what I'm saying is, hey, that big list of objects that's connected to the slider, send them nothing. So that's terrible. So let's just plug value into that. No problem. Compile and save, and then try again, this time with less terribleness. Oh, it's already receiving 1250. That's great. So, whoop, 5,000. So we're actually driving two things at the same time with one slider. How cool is that? And you can attach anything you want to this. The nice thing about it is the slider is always going to send a value between 0 and 1. You can multiply that by anything you want, or use it like we did as an alpha to lerp between a min and a max value, and it'll always just work. And because the slider itself has this really keen list of objects to drive, you can just attach as many things as you want to it. So that wraps this up. This carried on for a little bit longer than I originally intended it to, but I wanted to, since I wasn't on anybody's clock, I wanted to take the requisite time to explain everything, make sure everything was working the way I thought it should. I apologize if audio on this isn't perfect. I'm not in the studio. I'm totally just sitting at my desk recording this kind of off the side. Hopefully this shores up any remaining questions that were left over from the live stream that I had to cut off early. I want to thank you all for checking out our live streams, for being a part of the Unreal Engine. Show us what you're doing. Continue to be great. Let's all make games or whatever it is you want to make with the engine together. It's not all about games anymore. And I'll catch you all on the next stream. See ya.